And this portion is going to go over how to create the measurement plans from the actual 3DCS CAD. So I'm going to go back to the model I have here. So what this is going to do is we can see these points here that we have on the model. What we're going to do is we're going to export these points into a format that can come into QDM. The reason for this is that the QDM software can provide either a PDF or a CSV, Excel, Notepad file for the CMM operator. So that way that the inspector is inspecting at the exact same XYZ points as the points that were created in the model. So what I'm going to do is under our 3DCS tab at the top, we have save load, we have export DB2. The DB2 is a data file that easily goes from 3DCS to QDM and back and forth. So when I click on this, small window here says click on part. So it's asking what part I would like the data file from. I could pick the assembly and it would create a data file for every part. For the concept of this, I'm just going to pick the one part. So I pick the outside cover. Can save that part, or I can save that data file. So now within QDM, you just close this one. You close this. Close a couple of these. I'm going to open the top cover measurement plan. So this particular example, there's been some images of the actual GD&T uploaded into the QDM analyst software. So this is a JPEG, has the top cover, it has the datums on this page. We have the revision number, things along those lines. The next page, we have the tolerances. So with this image being within QDM analyst, the operator of the CMM or the dimensional engineer, quality engineer has all this in one place rather than opening a PDF from a server or downloading it, things along those lines. So now the operator, quality engineer has this page to reference the different points. So what I did is QDM, the inputs being the 3D CAD. In this case, it was a CATIA part. I mean, we can do NX parts, Creo parts, step files, and many more. So what's been brought in here, let me just make this full screen. We have the actual name of the point, we have the position, XYZ, and we have the IJK direction. So this is useful for the operator of the CMM, so they don't have to go through and type these numbers all within the CMM machine. They can export a file from QDM that has it in a table format. So I can go through these different pages here. This particular one's broken up by this left cover datum points. As we can see here, we have a two-way, four-way, different things like that. A couple up-down pads. Right cover datum points. Final assembly measures. So it also is identifying the points that are for the final assembly as well as the piece part with the point name XYZ IJK. Here's just a quick roadmap. All it has is the point names with a leader line, and it's all the 3D CAD again. So this is how the standardization, go back to the PowerPoint slide here, measurement standardization. So this is how we create the measurement plans from the 3DCS workbench. So moving forward a little bit from the measurement standardization, we're able to identify with the CMM operator where they can measure. And once the measurements take place, it kind of flows here with what we call closing the loop. It was part 3 of our webinar last month. So I'm not going to dig into the particular details too much other than an overall quick overview of taking the actual measured data. So the 30-piece sample, 6-piece sample, whatever piece sample you have, and replacing the design tolerances with that measured data. With the 3DCS model and the 3DCS measurement points going into a DB2 file. This is just a plant data file that we're using in this example that can be populated into the QDM template and shared with the CMM operators for ease of use.
Did you show the output of that DB2 file?
I can definitely show that. So in this particular case, a DB2 file, again, this is just a DCS in-house file that has things like the XYZ of a point, has the nominals of a point, the upper and lower spec limits, IJKs, and along the bottom here, let me just make things a little bit bigger. We have point names, and this particular one that I opened up has one sample that was inspected. So this file with the XYZ, nominal, spec limits, IJK, this portion of this file can be exported or copied for the CMM operator so they're not typing in. In this case, looks like we have 77 points and we have 9 different columns. So instead of the manual operation, we kind of have everything in one place, make it easier to share and use.
I'd like to say something. This is Gary Bell. I always jump in and say a few words just so people don't forget who I am. This is a two-way street. He's talking currently about taking points in a 3DCS model and passing them out so that you can use them to collect CMM data. If you already have these points defined and you can get it in this format, then this can be brought back in and we will automatically create the points in the 3DCS model so that we're still coordinated. So we can go from the model to a measurement plan or from a measurement plan to a model, depending on who has the data first.